better oil-driven pump because it's easier to maintain it that way. Leave it overnight, pull all that off, and this is what we end up with. So again, cathode. If you're doing the cathode active material that we use is lithium manganese oxide. There's others that the battery industry is looking at, lithium iron phosphate, lithium cobalt oxide, are the three big ones that are commercial right now. There's some blends that are really gaining interest, but lithium manganese oxide is the one that we're most interested in because it is in the volt, and it's the troublemaker. It has manganese in it, and if you know your chemistry, manganese undergoes ion-Teller distortion. The ion-Teller distortion generates manganese 2. Manganese 2 is soluble. Once you start dissolving away your cathode, you lose capacity, and you can short out your battery because once it goes to the anode, it inflates, and you have metal, and it starts growing back to the cathode. And just cats and dogs living together.
So you remember crystal defects that they were just talking about? That's ion-Teller. It turns out stuff in too much lithium or take out too much, you get a localized dislocation, just like they were talking about, and that's bad for the battery because now you can't put lithium back in.
Okay, so once we have that, the anodes are very similar. We put them on copper because of the potential of the anode, and we use graphite. Fancy graphite, but it's graphite. So from there, everything gets cut to form. We have one of two options. We have a coin cell, which is just like your watch battery. We use 2032s. We just cleaned up, so of course there's none floating around in here. Or we do pouch cells. If it's a round coin cell, we punch it out. If it's a pouch cell, we just cut strips. Everything comes in here and gets sealed hermetically. So we don't have a problem with all of this other material outside of the glove box. But once we get the electrolyte involved, it has to be in the glove box. This is an argon atmospheric glove box. The reason we do that is because we can control the moisture. The electrolyte salt is lithium hexafluorophosphate. Lithium hexafluorophosphate hydrolyzes very easily, makes HF acid. HF acid is A, really bad for you, B, it's really bad for the battery too because it dissolves everything. Again, you start dissolving your manganese, you start dissolving your current collectors, and your battery goes to hell faster than you want it to. Then once you have the batteries made, we take them out, we send them over to Joe to test them. One of the fun things we have in here, if you see this big crazy device with the giant red button, that's one of the things that Joe and I made. Our pouch cells, we were having issues trying to convince them to seal really well. Basically, it's a glorified seal anneal. And a lot of people have tried using seal anneals like the one there on the counter. The problem is that A, you can't control the temperature, you can't control the time, and it only heats on one side. That's great if you're sealing plastic to plastic, but when you have a current collector tab sticking out, and you'll see examples of these batteries over in the other room, it acts as a heat sink. So it's really hard to get the plastic to melt to the heat sink. Because it just cools off too fast. So what we did here was we developed, at the top, it's a pneumatic piston that drives the top aluminum bar down to the bottom aluminum bar. There's 2 heater cartridges in there so we can control the temperature, we can control the time, we can control the pressure. And we have a giant red button as an homage to evil scientists over there. What am I forgetting? Oh, and in the pouch cells, we vacuum seal them. So this is a fancy vacuum sealer. Everybody's seen the kind like on your counter where it just sucks it flat. This does the same thing, except the cell is inside the entire chamber. The reason we do that is that if you are evacuating the atmosphere around the pouch at the same time you're evacuating the atmosphere inside the pouch, you don't boil off your electrolyte. And we have to keep the electrolyte in there if we're going to have ions flowing back and forth. I'm really sorry I don't have a sample of these cells. Shocked and appalled.